this session, we shall go through some more important problems in areas using definite integral concept. At the very first problem, we know the area of a loop of sine curve is 2 units and that of a cos function is also 2 units. Okay, now of special interest is the case of finding the area bounded between the two curves y is equal to sin x and y is equal to cos x between two successive points of intersection. That is the case now. What is it? We are going to find the area bounded by y is equal to sin x and y is equal to cos x between two successive points of intersection. That is the question. Now, let us observe the graph. Pi by 4, pi by 2, pi, 2 pi, 3 pi, like that. Sin 0 is 0, whereas sin 90 is 1, sin 180 is 0, sin 180 is 0. Like that it goes on. Pi by 2, pi, 3 pi by 2, 2 pi. Whereas for cos x, cos 0 is 1, cos 90 is 0, cos 180 is minus 1, cos 270 is 0, like that. Okay friend, where do these two curves meet? The first point of intersection is pi by 4 and this is this point is 5 pi by 4, that is 225 degrees. So our required area is the area bounded between the two curves between successive points of intersection. And it is very clear to observe these two functions y is equal to sin x and y is equal to cos x do meet at pi by 4 and 5 pi by 4, that is 45 degrees and 225 degrees. If you can find this area, such type of points, pairs of points of intersection, you can observe a lot. Between those two also, area will be the same by the symmetry of sine function and cos function. Therefore, it is our duty to know the area between these two points of points of intersection of the two curves. Well, how to get it? You please think of the graph. You note down the graph first, and it is very simple. This is y is equal to sin x and this is y is equal to cos x. Hence, anybody can easily trace that required area lies between x equal to pi by 4 and x equal to 5 pi by 4. The required area is integral pi by 4 to 5 pi by 4. The upper curve is sin x minus cos x dx. Area bounded between f of x and g of x. The two curves f of x and g of x is mod f of x minus g of x. Here it is sin x minus cos x between the limits pi by 4 and 5 pi by 4. Good. What is sin x? Integral of sin x is minus cos x. Integral of minus cos x is minus sin x. Minus cos x minus sin x between the limits pi by 4 and 5 pi by 4. Sin x minus cos x dx. Integral of sin x is minus cos x and minus integral of cos x is sin x, and if you substitute the limits, the answer will be 2 root 2. Answer will be 2 root 2. That is the answer. The next question comes to us is the area of the curvilinear triangle formed by y is equal to sin x and y is equal to cos x between x equal to 0 and x is equal to pi by 2 is. That is the question. The area of the curvilinear triangle formed by y is equal to sin x and y is equal to cos x between x equal to 0 and x equal to pi by 2 is. What is that? So, to have the meaning, we must approach the nature of the graphs. How do they look? Well, so of course the boundaries are x equal to 0 and x is equal to pi by 2. Let us first take interest in looking towards the graphs. Between 0 and pi by 2, let us observe the nature of the two graphs y is equal to sin x and y is equal to cos x. This is y is equal to sin x. This is y equal to cos x. And the so-called curvilinear triangle formed is this. And they do meet at pi by 4. Of course, this area plus this area we require. We require 0 to pi by 2. Good. From 0 to pi by 4, the curve available here is y is equal to sin x, and from pi by 4 to pi by 2, we are supposed to have the area under cosine curve. Therefore, required area is equal to integral 0 to pi by 4. Come on friend, you observe in this region under what curve we are moving? Sin x. So 0 to pi by 4 sin x dx plus integral pi by 4 to pi by 2. In this region we move under the curve y is equal to cos x, isn't it? Cos x dx. What is the integral of sin x? Minus cos x between the limits 0 to pi by 4 plus what is integral of cos x? It is sin x between the limits pi by 4 to pi by 2. Pi by 4 to pi by 2. Now, let us observe the simplified form. This is equal to minus. What is cos pi by 4? 1 by root 2. What is cos 0? 1. Okay, come here. Plus, what is sin pi by 2? 1. Minus sin pi by 4? 1 by root 2. All together, what is happening here? 1 minus of minus 1 is 1. 1 plus 1, 2. Minus 1 by root 2, minus 1 by root 2, minus 2 by root 2. Minus 2 by root 2 is nothing but root 2. So it is minus root 2. So what is the required area of this simple small curvilinear triangle formed by the two curves y is equal to sin x and y is equal to cos x? Answer is 2 minus root 2. Yes, so many square units as it is to be used in expressed in square units as it the area. We write so many SU, that is square units. This is the beautiful problem. The next question, the area bounded by between y square is equal to 4x and its latus rectum. Its latus rectum is. This is one of the standard questions and standard answers. You must be able to have the answer immediately on the spot by looking at the parabola itself. For that, let us try to derive the answer. Of course, it is 8a square by 3, and let us see how does it come. Look here. What is the area required? Parabola y square is equal to 4ax and its latus rectum. Well, let us observe the graph first of all, because that is the main soul of the answer. Yes. Let this be the parabola y square is equal to 4x. We know that its focus is A0 and its latus rectum is the line passing through the focus and perpendicular to the axis of the parabola. That is, its equation is x is equal to a, isn't it? Okay, let us have its latus rectum. This is A0. A0. Well, one of the finest things that one should observe here is the curve y square is equal to 4ax bears the even parts of y, hence it is symmetric about x-axis. Symmetric about x-axis. And you can easily look at this is of course the required area. This is the required area. But you see, we find this area only because this area and this area are one and the same. Therefore, required area is equal to 2 into integral 0 to a. This is 0, 0, isn't it? This is A0. We are interested to find this area. We move under this curve. This is nothing but y square is equal to 4x, isn't it? In the first quadrant, what is y? Root of 4ax, isn't it? It is root 4ax dx. This is nothing but root 4 is 2, 2 2s are 4. 4 root a into integral 0 to a root x dx. 4 root a into integral 0 to a root x dx. Therefore, this is 4 root a into what is the integral of root x? It is 2 by 3 into x root x between the limits 0 to a. 0 to a. It is root x is x power half. Its integral is x power half plus 1 by half plus 1. That is x power 3 by 2 by 3 by 2. 2 by 3 into x power 3 by 2. X root x is nothing but x power 3 by 2. No problem in it. Okay then. It is 4 into 2 by 3. 8 by 3 into root a into x root x between the limits 0 and a. What can it be? It is just nothing but a root a minus 0. That is a root a. Root a into root a. A into a square. Hence it is 8a square by 3. 8a square by 3 units. It is famous and important because the reusability of the formula is there. what is the area bounded by the parabola y square is equal to 4x and its lattice rectum? Suppose he asks the question like that. Y square is equal to 4x. In the place of 4a, we have 4. So a is 1. Hence the answer is 8 by 3. 8 by 3. What is the area bounded by the parabola y square is equal to 12x and its lattice rectum? What is the answer? Look here. What is 4a? Y square is equal to 4x. Instead of 4ax, we have 12. So 4a is 12. So a is 4a is 12. So a is 3. Hence the answer is 8 into 3 square by 3 and it is 24 square units. Like that, you can be in a position to estimate the answer on this part itself, of course, by remembering this result. 8a square by 3, so many square units. So many square units. Next. The next question before us is the area bounded between the parabola y square is equal to 12x and the double ordinate x is equal to 6. X is equal to 6. What is the meaning for that? Again, let us observe the graph of this parabola. This is y square is equal to 12x. So in the place of 4a, we have 12. I think you could have understood the question. What is the area required? Parabola and one of its double ordinates. What is a double ordinate? A double ordinate is the segment perpendicular to the axis of the parabola and meeting the parabola at two different points. Yes, of course. This is a is 3. Here it may be 3. Then let us extend it. This is x is equal to 6. Eventually and evidently, if the double ordinate passes through the focus itself, it is just nothing but the lattice rectum. So, double ordinate is parallel to lattice rectum. Whatever it may be, the line, rather the double ordinate which has been given here is x is equal to 6. And as in the previous case, you can easily observe that this area, it is enough if you can find this area. If this is x, this is also x. These two are one and the same, simply because of the symmetry of the parabola y square is equal to 4x about x-axis. Well done. Required area is equal to 2 into integral 0 to 6 y square is equal to 12x. So y is equal to root 12x dx. Root 12x dx. So this is equal to 2 root 12 into, what is integral of root x? 2 by 3 into x root x between the limits 0 to 6. Okay, what is root 12? Root 4 into root 3, that is 2 root 3. 2 into 2 root 3 into 2, altogether 8 root 3 by 3. 8 root 3 by 3 into x root x means 6 root 6. Total, if we can cancel 3 here, 2 into 8, 16 into root 18 gives you the answer. 3 will be cancelled twice. 2 8s are 16 into root 18. Root 18 is again nothing but 3 root 2. So it is 48 root 2, so many square units. So actually speaking, there is no change in the dealing or constructing the figure, even it is lattice rectum or double ordinate. It makes no sense at all, no difference at all in the style of integration. Hence here the answer is 48 root 2. Let us now create a generalized result to have the answer in the question, the previous questions type questions. In the questions of the previous type, let us see the area bounded by y square is equal to 4x and x is equal to k is a positive, k positive. What do you mean by x is equal to k? It is just nothing but double ordinate, isn't it? Passing through k0 perpendicular to the axis of the parabola. Observe the graph. That need not be the lattice rectum. It is just a double ordinate, of course, passing through the point k0 on x-axis, that is axis of the parabola. And we require the area, this area. As usual, we generally find this area and double it to get the required area. Okay, required area is equal to two into integral 0 to k, isn't it? Integral 0 to k, y square is equal to 4x. In the first quadrant, what is y? It is root 4x dx. Root 4 is 2. 2 into 2, 4. 4 root a into, what happens? Just root x only remains. What is the integral of root x? 2 by 3 x root x between the limit 0 to k. Altogether it is 4 2s are 8. 8 by 3 root a into k root k. Into k root k. So by knowing a and by knowing k, you will be having the area. You can substitute these values for the previous problem also. You will be able to have the area. So this is also having a reusable nature. Yes. Suppose the parabola is y square is equal to 12x and the double ordinate is x is equal to 6. Isn't it the previous problem? Okay. Here in the place of a, what do you have? 3. And in the place of k, what do you have? 6. 8 by 3 into root 3, 8 by 3 into root 3 into 6 root 6. Cancel this 2 here. 16 into root 18, that is 3 root 2. 16 into 3 root 2, that is 48 root 2, which is exactly the previous answer we could have obtained, isn't it? Therefore, you please mind this particular answer in your mind. You keep that in mind. Area bounded by the parabola and its lattice rectum is 8a square by 3, 8a square by 3, whereas the area being bounded between the parabola y square is equal to 4x and the double ordinate is in the formula 8a square by 3, 8 by 3 root a is okay. Still we have a root a to have a square. Instead of a root a, we have k root k. That's all. You see, you put k is equal to a here. What happens? It becomes a lattice rectum. Root a into a is nothing but a square. So the original answer 8a square by 3 has been distributed as 8 root a by 3 into k root k. That's all. That is the area between the parabola and its double ordinate. Okay. We have just noted that the area between the area bounded by parabola and its lattice rectum is 8a square by 3, isn't it? It is for y square is equal to 4x. If I change the parabola as x square is equal to 4ay, what happens to the similar area? Area bounded between the parabola x square is equal to 4ay, x square is equal to 4ay and its lattice rectum. You can easily find, of course, then the diagram becomes like this. This is x square is equal to 4ay and the lattice rectum is y is equal to a, isn't it? The lattice rectum is y is equal to a. This is y, equation is y is equal to a. Come on, tell me the points here. What are the points here? This is 0 comma a. If you put y is equal to a here, x square is equal to 4a square, so x is 2a. Hence, this is the point 2a comma a. And this is the point minus 2a comma a. Minus 2a comma a. We want this area. This is A. This is also A. This is 2A, this is 2A. Isn't it? Therefore, this area of this rectangle is 2A plus 2A, 4A. 4A into A is 4A square. 4A square minus integral minus 2A to 2A. What is this? X square by 4A. It is an even function. It can be taken as 4A square minus 2 into integral 0 to 2A x square by 4A dx. So it is 4A square minus 2 by 4A into x cube by 3, that is 1 by 3 into x cube between the limits 0 to 2A. Altogether this is 4A square minus 1 by, this is 12A, 1 by 6A into 8A cube. 4A square minus 4A square by 3 is just nothing but again 8A square by 3. So many square units. Therefore, there makes no difference at all whether the parabola given in the problem is y square is equal to 4x or x square is equal to 4ay. The area remains the same. What is that area? Area bounded by the parabola y square is equal to 4x or x square is equal to 4ay, and its lattice rectum is 8a square by 3. 8a square by 3. It makes no difference at all. That is the area. Well, next.